Alright, so this video I'm going to continue to discuss the Le Chatelier principle, the pressure. Okay, now actually the pressure and the volume we going to combine to talk together because they're talking about the gas system only, and pressure and volume is only for gas system. So if you don't really remember the Boyle's law, P1 V1 equals P2 V2. So when pressure increase, volume will decrease, and when pressure decrease, volume will increase. So they go opposite. Okay, so this is the final result when you increase the pressure or decrease the pressure, and these are the reasons you can put it on the worksheet. So I can go to the back. Sorry that I make. Okay, so again, it's only for gas system only. So when pressure increase, okay, let's say I press more down, volume will decrease. Okay, it makes sense because if you press the gas system, right, the volume will be like smaller. So they go opposite, right? When pressure increase, volume go down. Okay, so when volume press like smaller, it looks like the molecules are come closer. So I make up the story. I say, okay, if the molecules come closer because the volume is smaller, the molecules start to fight. Okay, so I need to take away most of the gas. Okay, so I take away some. So instead of like 9 gas molecule, I now only have like 6. Okay, so my equilibrium will shift to fewer moles of gas. Okay, and then when the pressure go down, all right, when you have less pressure, volume will expand. Okay, so pressure go down, volume go up. So then the particle will spread apart. When the particles spread apart, they will feel lonely. So I need to bring more molecules. Okay, so instead of 6, by now it could be like 9. So my equilibrium will shift to the more moles of gas. So let me just go back to have the story again. Is when volume go up, when pressure go up, volume go down. Volume go down, you guys come closer, you fight. I need to take some molecules out, so you will prefer to fewer moles of gas. And then when pressure go down, volume go up, you guys spread apart, you feel lonely. I need to add more molecules to making friends, so you will shift, the equilibrium will shift to more moles of gas. Okay, so now are we also with this? We can come back to the worksheet 2 here. So we first need to make sure that 3 things is like is it a gas system? It is an XO endo. Now XO endo is talking about temperature. I already explained how to find out XO endo in the worksheet 1. And then number 3 is we need to find out the moles of gas on both sides. Okay, I say moles of gas on both sides if this is a gas system, and we just need to add up the coefficient. So right here, this number 1 here is, yes, it is gas system because I have gases. And then there's no information about XO or endo. It means that the reaction takes place without losing energy or gaining energy, which is fine. And then we need to add the moles of the gas. So here is 2 moles of gas, here's 2 moles of gas. Now, when we start talking about volume of pressure again, it depending on like it will like shift to fewer moles or more moles of gas. Now since we have equal moles of the gas, you're changing volume, you're changing your pressure, will be no shift because they have equal number of moles of the gas on both sides. So I don't really care. Okay, actually this should be equal number of moles of gas. Okay, of gas. Okay, equal numbers of moles of gas on both sides. So no matter you change your volume or pressure, will be no shift. And now here it is a gas system. Now there's no endo XO information, which is mean like reaction take place not losing energy, gaining energy, which is fine. Now here be careful. Some people will just ignore the state, will say, oh, we have 7 moles, which is wrong. Here we don't count the solid. We only look up the gas molecule. So it will be just 4 moles of molecules. We look up the coefficient. Okay, we ignore any solid or liquid. So here will be 4 moles of gas, 4 moles of gas. And then for number 4 and 5, same thing, no shift because you have equal number of moles of gas on both sides. So your changing volume or pressure will be no shift. And then if you add more iron to the system, now iron is a solid. So if we go back to the yellow table here, if you have the gas system, when you changing the solid or liquid, will be no shift in the gas system. Okay, will be no shift. So here we will write no shift because iron is a solid in the gas system. Okay, so iron is a solid in the gas system. All right, now here it is the gas system, and this is the equilibrium signal, and then the energy is on the left hand side. That means it is absorbing energy. Okay, it's on the left hand side, it's absorbing energy as the reactant, so that means energy is coming in. So this is an endothermic system, and then the most of the gas will be 3 and 2. So here is if you increase the volume, so if you don't need to talk about pressure here because all actually we're using volume as the direct factor to determine. So you don't really need to talk about pressure if we start with volume. You can just go ahead to use volume. But if the question starts with pressure, then you say pressure, what happened, and then volume, what happened. But here, we can only start with volume because volume is the direct factor to determine your answer. So when volume goes up, I remember the story I told you, when the volume goes up, you guys spread apart, you feel lonely, I need to bring more gas, so my equilibrium will shift to more moles of gas. So because of this, I will shift to LEP because the LEP had 3 moles, the right hand side only had 2. And then when pressure is decreased, same thing, when pressure decrease, volume increase, so most of gas will go to the left. Okay. Now here will be gas system, 9 moles of gas, 10 moles of gas, no endo XO. So if no endo XO, either you increase temperature or decrease temperature, will be no shift because the system is neither XO or endo. And here is if you increase the pressure, okay, if you increase the pressure, pressure goes up, volume go down, you guys come closer, you guys need to fight, so I need to bring some molecules out, so I will have fewer moles of gas left over, so I will shift to left. And then the number 19 is when you add an inert gas. Now inert gas is a gas that is not part of the system. It's just like a gas that is like not related gas, okay? But when you get at the gas in the system, finally the thing is the total volume will be more because you add extra gas, even though the gas is not part of the system. Okay, but the gas will be the inner gas will make the volume expanded. Okay, and let me go to the back. The back I don't have time to talk about that in class. So first of all, we barely talking about the double displacement. Neutralization is when you have acid, which is H plus, base, which is OH minus. When they neutralize, you have water. So if you doing the neutralization, H plus will be used up, OH minus will be used up. So right here, the question is, first of all, we need to identify the equilibrium signal. Right? The energy is on the left-hand side, so will be, you know what kind of system it is. And then we need to highlight H plus. Okay. Now here, we keep talking about we prefer product, we prefer reactant. Now here, the reactant, if you want to shift to the reactant will form yellow color. Okay, so because ClO4 is yellow color. If your equilibrium will favor to the product side, now my product side, one of the product will be orange color because Cl2O7 2- is orange color. So every time when we're talking about you prefer go to form more product or prefer more reactant, if you prefer more reactant form, it means that H plus will be increased, ClO4 2- will be increased. If you prefer to form more product, that means Cl2O7 will be increased, H2O will be increased. So here, the only thing I want you to talk about is if you add HCl is the acid. So if you add HCl, the consequence is actually you make the H plus concentration go up. So if it go up, I want to stay away from H plus. So I will shift to the right hand side. If I want to switch to the right hand side, my color will be orange. And if you add NaOH, now here I don't have NaOH. But if I add NaOH, the OH will neutralize the H plus. Okay, here I don't have NaOH. But if I add NaOH, the OH minus will neutralize the H plus here. If I neutralize the H plus here, the H plus will use up. So then H plus concentration will be going down. Okay, the H plus concentration will be going down. So you have to be careful. Do you have H plus or do you have OH minus in the equation? Right, now same thing on here. Okay, we don't have H plus, but we have OH minus. If you OH minus, if you add HCl, okay, HCl is going to neutralize. Oh, I'm sorry, this actually is neutralize the OH minus. Okay, it's going to be neutralize the OH minus. So OH minus will be used up, and then my OH minus will be going down. Okay, my OH minus will be going down. Okay.